There is a quantity of iron in your blood, a few grams in all, threaded through the hemoglobin that carries oxygen from your lungs to every living cell. It is an unremarkable amount, less than the mass of a small nail, and yet not one atom of that iron began here. None of it was made on Earth, or by the Sunday, or anywhere within the comfortable reach of the world you know. Each of those iron atoms was forged in the heart of a massive star, under pressures and temperatures no human instrument can reproduce, and then flung across the galaxy by an explosion violent enough to outshine 100 billion suns. The same is true of the calcium in your bones, the carbon that forms the backbone of the organic molecules that make you alive. These atoms were assembled in places you will never visit, under conditions you could not survive, long before the Earth itself existed. Even the most ancient atoms in you, the hydrogen older than any star, were not made here either. They were built in the first minutes of the universe. Wherever you look in your body, the origin lies elsewhere. Every atom in you was built somewhere else. To understand what this means, it helps to begin not with the body, but with the beginning, because the story of your atoms is the story of cosmic history compressed into flesh. In the immediate aftermath of the Big Bang, there were no atoms at all. There was only a searing, formless density of energy and particles, too hot for anything stable to form, expanding and cooling at an extraordinary rate. As the first minutes passed and the temperature fell, the simplest nuclei began to condense out of the chaos, protons and neutrons binding together. But the window for this primordial cooking was brief. The universe thinned too quickly for much to be made. When it closed, the cosmos consisted almost entirely of the two lightest elements: hydrogen, the simplest of all, a single proton, and helium, with a trace of lithium besides. Nothing heavier survived in any meaningful quantity. There was no carbon, no oxygen, no nitrogen, no iron, none of the raw material of planets or chemistry or life. The early universe was a vast, simple sea of the two plainest ingredients imaginable, and nothing else. This is the first and strangest fact to absorb. Most of the hydrogen in your body, the hydrogen bound into every molecule of water that makes up some 60% of your mass, is very nearly as old as the universe itself. It has existed, essentially unchanged, for more than 13 billion years. The hydrogen in the water on your tongue predates the Sunday. It predates the Earth. It predates the oldest stars you can see in the night sky. It was born in the first few minutes of time and has been waiting, in one form or another, ever since, to be incorporated briefly into the temporary arrangement of atoms, that is you. But hydrogen and helium alone cannot make a person. For everything else, for the carbon and oxygen and iron and calcium, the universe needed factories, and it had not yet built them. The factories were the stars, and they were assembled out of that same primordial gas. Across hundreds of millions of years, the faint clouds of hydrogen and helium left over from the Big Bang drifted under their own gravity, drawn slowly together, growing denser at their centers. As a clump of gas contracted, it heated, and when its core grew hot and dense enough, something unprecedented ignited within it. The hydrogen nuclei, ordinarily flying apart from their mutual repulsion, were forced together so violently that they fused, merging in stages into helium and releasing a flash of energy in the process. This is nuclear fusion, the engine of every star, and it accomplished something the Big Bang had failed to do. It began slowly and steadily to build heavier elements out of lighter ones. A star is, in the most literal sense, a place where the universe transmutes one kind of matter into another. And it does so not in an instant, but across millions or billions of years of patient burning. For most of its life, a star like the Sunday does little more than fuse hydrogen into helium, a stable and unhurried process that can sustain it for 10 billion years. But this alone does not produce the elements of life. The richer chemistry begins only when a star approaches its end. When the hydrogen in the core runs low, the balance that held the star steady falters. The core contracts and heats further, and a new threshold is crossed. The helium that had accumulated as ash now becomes fuel in its own right. 3 helium nuclei, under the crushing conditions of the dying core, fuse together into a single nucleus of carbon. This is the origin of the carbon in your body, the element on which all known life is based, the framework of your proteins and your DNA. It is made only in the late stages of a star's existence, in a reaction so finely balanced that for decades physicists struggled to understand how it could happen at all. Every carbon atom in you was assembled 3 helium nuclei at a time, in the core of a star that had already lived most of its life. And once carbon exists, oxygen follows close behind, carbon fusing with another helium nucleus to produce the oxygen that fills your lungs with every breath. What happens next depends on the size of the star, and here the story divides into two paths. A modest star like our Sunday will never grow hot enough to fuse elements much heavier than carbon and oxygen. As it dies, it swells into a red giant, becomes unstable, and gently sheds its outer layers into space. Exhaling the carbon and oxygen, it is manufactured in a slow, expanding shell of gas. These shells, glowing and intricate, drift outward and enrich the surrounding galaxy with the products of the star's lifetime. The dying Sunday will one day do exactly this, returning to the galaxy the elements it spent billions of years creating. By fusion, such modest stars cannot build much beyond carbon and oxygen, though in their aging years they can assemble small amounts of heavier elements by slowly capturing stray neutrons. The heavier elements, in bulk, demand something far more extreme. A star many times the mass of the Sunday lives fast and dies catastrophically, and in its brief, furious life it becomes a layered furnace, fusing ever heavier elements in concentric shells around its core. Carbon fuses into neon, neon into oxygen, oxygen into silicon, and silicon, at last, into iron. Each stage requires higher temperatures and proceeds more rapidly than the last, until the final stages last not millions of years but days. The star becomes a kind of onion of nuclear ash, each layer burning a different element, all of it building toward iron at the center. And at iron, the process abruptly stops, for a reason written into the deepest structure of matter itself. Iron sits near the very peak of nuclear stability. Fusing it into anything heavier no longer releases energy. It consumes it. The moment a star's core becomes iron, the fire that sustained it can no longer burn. The furnace, in an instant, goes cold. What follows is among the most violent events in the universe. With its energy source extinguished, the iron core can no longer support the immense weight of the star pressing down upon it. In a fraction of a second, it collapses, falling inward at a quarter of the speed of light, compressing matter to densities beyond comprehension. The collapse halts abruptly when the core can compress no further, and the infalling outer layers, crashing down onto this suddenly rigid center, rebound in a shock wave of unimaginable power. The star explodes as a supernova, briefly outshining its entire host galaxy, releasing in seconds more energy than the Sunday will radiate across its whole 10 billion year life. In the searing storm of that explosion, some elements heavier than iron are created, forged not by the slow patience of fusion, but in the violence of the blast itself. And then the explosion scatters everything, the carbon and oxygen, the silicon and iron, the heavier elements stirred up in its death throes, hurling them out across light, years of space, to mingle with the gas of the galaxy. For a long time, astronomers believed that supernovae alone accounted for most of the heaviest elements. But the picture has grown richer and stranger. Some of the heaviest and most precious materials, the gold in jewelry, the platinum in industry, much of the silver and the rare earths, appear to require an event even more exotic. When a massive star dies, its collapsed core can remain behind as a neutron star, an object so dense that a single teaspoon of its material would weigh as much as a mountain. And when two such neutron stars, locked in a mutual orbit, finally spiral together and collide, the collision flings out a spray of neutron, rich matter that rapidly assembles into the heaviest elements in nature. In 2017, astronomers observed exactly such a collision for the first time, detecting both the ripples it sent through space-time and the light of its aftermath, and confirmed that these cosmic crashes do indeed manufacture gold and platinum in vast quantities. If you wear a gold ring, you are very likely wearing the debris of a collision between two dead stars, an event so rare and so violent that it shook the fabric of the universe. All of these processes, the slow exhalations of dying suns, the explosions of massive stars, the collisions of stellar corpses, share a single consequence. They take the elements manufactured deep inside stars and return them to the space between the stars, enriching the thin gas of the galaxy with carbon and oxygen and iron and gold. And that enriched gas does not simply dissipate. Over millions of years it drifts and gathers, pulled together once again by gravity into new clouds, which collapse to form new stars, and around those new stars, new planets. Each generation of stars seeds the next with the products of its life and death, so that the galaxy grows steadily richer in heavy elements with every cycle. The universe is, in this sense, a vast and patient recycler, building stars, harvesting their elements, and building again. Our own Sunday is a product of this recycling. A relative latecomer, formed some 9 billion years after the Big Bang from a cloud of gas already enriched by countless earlier stars that had lived and died before it. The evidence is in the planets around it. The Earth is not made primarily of hydrogen and helium, the original elements of the cosmos, but of iron and oxygen and silicon and carbon, the manufactured elements, the products of stellar life and death. The very existence of a rocky planet like ours is only possible because earlier generations of stars had already produced the raw material from which it could form. The Earth beneath your feet is, quite literally, the recycled ash of dead stars, gathered together 4.5 billion years ago from the enriched debris of the galaxy. And from that debris came you, the carbon in your cells, the oxygen in your blood, the iron in your hemoglobin, the calcium in your bones, the phosphorus in your DNA. These heavier atoms were all made in stars or in their deaths, scattered across the galaxy, gathered into the cloud that became the solar system, and cycled through oceans and rock and air and countless living things across billions of years before being assembled. Briefly, into the particular arrangement that is you, the atoms are almost incomprehensibly old. They have existed for billions of years, and will exist for billions more. Your body is not their origin, but merely their current address, a temporary configuration they will inhabit for a few decades before being released again, to be taken up by the soil, by plants, by other creatures, by the slow machinery of the planet that will continue long after you are gone. There is a temptation to treat this as mere sentiment, the kind of cosmic flattery that makes a person feel briefly significant. But it is something more rigorous than that, and in a way more humbling. You are not separate from the universe, observing it from the outside. You are made of it, built from the same atoms that compose the stars and the planets, and the empty dust between them, assembled by the same physical processes that govern everything else. The boundary between you and the cosmos is not a boundary of substance, but only of arrangement. The atoms that think these thoughts and read these words were forged in the early universe, and in stellar fire, scattered by explosions and collisions that occurred before the Earth was born, and they have simply, for a little while, come together in a form complex enough to wonder about its own origins. The universe, in you, has produced something capable of looking back at the stars and recognizing, correctly, that it is looking toward the place where it was made. Every atom in you was built somewhere else, and somewhere else, it turns out, is written across the whole of the sky.